Hello everybody, this is our project, Stereo Vision based autonomous robot navigation and environment modeling system. I'm Rajit and we are PIT 40. This is our agenda of the presentation. I will give brief introduction about our project. Our main concept is the stereo vision, which is like human eyes. In robots, it determines the depth of the view by using two cameras. So the visual disparity of two different images is the key factor of determining the depth. So why we choose stereo vision? Because we found out that it has many advantages over other traditional technologies, and especially it's a low-cost solution. So our project is a small 3-wheel robot which works through two servo motors with two web cameras. Also, it's generate the occupancy map, and by using that determine the instructions and finally generate a 3D model of explored area. So this is how we achieve our concept of stereo vision, by using two web cameras. So that's all for my brief introduction, and Rukshan will explain more about the objectives of our project.
Thank you, Rajit. I'm Rukshan and I would like to explain about the objectives of this project. We have a main general objective in this project, which is to provide a solid guidance to future researchers regarding automated vehicle or any intelligent robot that operates in a dynamic environment. So with a system like this, a robot or a vehicle can navigate in dynamic environment without any human interaction. That's the general objective of this project. And also we have specific objectives. Those are generate and update the occupancy map of the explored area in two-dimensional model during the entire journey. And using this occupancy map, this system is capable of developing a simple 3D model of the explored environment. This feature is very useful. By combining this with a powerful robot, will provide an excellent way to explore unreachable areas by humans, and also we can get a clear idea of the explored area by simply looking at the 3D model. Those are very specific objectives of this research. And that's all about the objectives of this project, and my next colleague will explain the architecture of this system. Thank you.
Thank you, Rukshan. This is our architectural diagram. Our robot having two web cameras and two servo motors, and the major part of our robot is big microcontroller. It controls the movement of our robot. The two web cameras are communicated with PC using USB cable, and big microcontroller communicates through the serial port. According to the video feed from the two cameras, the system sends signals to the microcontroller, then the microcontroller controls the two motors. That's how our system works. Uniqueness. How our system is different from similar projects. Usually, computer vision is used for feature tracking or landmark sensoring, but we use computer vision for mobile robot to create bitmap and identify the obstacles. And also our system developed the 3D environment model for better understanding of explored area of our robot. This is end of my part, and my next colleague will continue the presentation.
Okay, thank you, Harinder. I think now you have overall idea about stereo vision, robot navigation and 3D modeling system. When we developed the system, that we used several tools and technologies. I would like to give brief idea about tools and technologies that we used. Core software is running on Microsoft.NET framework, and we used OpenCV for image processing engine for the best performance, and A4.NET used as the .NET buffer for the OpenCV library. In addition to that, we used SNA framework to render interactive 3D content. And also Microsoft is used to write the program for the PIC microcontrol, and those are the major technologies and framework that we use to implement our system. Now I would like invite my next uh, group member Chandler to demonstrate our system. Thank you.
This is the main user interface of our application. You can see the live video from the left and right cameras, as well as the generated depth map of the scene in front of the camera. Disparity locations window displays a green circle in areas with a disparity. Higher the density of the green circles, higher the disparity in a certain area. In depth map, darker gray levels indicate objects far away from the camera, while lighter gray levels indicate objects closer to the camera. As we move the object towards the camera and away from the camera, you can see the generated color of the depth map changes accordingly. Now we're going to have a test run with our robot. It's still in the development stage, so the movements are not very smooth. You can see the white pillar obstacle in front of the robot is detected by the system, and it turns the robot to avoid the obstacle and navigate in a safer path. Now we are trying to roughly demonstrate the generation of 2D occupancy map and 3D occupancy map.
Baiklah, 3D orang.
2D occupancy map generated by the software is later used to generate a 3D environmental map of the area, which is viewed inside a XNA based 3D viewer.
Azal stop kan buat ganon. Extend. Extend.